Hello, I want to show you this cool device which demonstrates resonance. It has two pendulums, one longer than the other. I measured their natural frequencies to be about 1.1 hertz for the long one and about 1.5 hertz for the short one. Now I will turn on the demonstration. The pendulums are both attached to a bar, which is attached to a gear using a string, where the gear is rotated by a DC motor, which is attached to a variable voltage DC power supply. There is also a voltmeter, which shows the voltage applied to the motor. The amount the bar moves is the same for both pendulums, and is relatively small, about 1/3 of an inch. Now that the bar has had a horizontal excitation for a few seconds, we can see that both pendulums move. However, the longer pendulum's motion is much larger than the shorter pendulum's. This is because I chose the voltage so that the string is pulling the bar at an excitation frequency which matches the natural frequency of the long pendulum. This causes the effects of many small pulls to produce a large effect, which is an example of resonance. Another way to describe it is that the bar is repeatedly pulling the large pendulum in a direction which speeds it up. Meanwhile, the bar sometimes pulls the small pendulum in a way which speeds it up, and sometimes pulls it in a way which slows it down. It is very similar to how pushing a child in a swing produces a large motion only if the child is pushed in a way that the child speeds up. This device is a more controlled version of the situation of pushing a child on a swing. I will now change the frequency of the bar excitation by changing the setting of the DC power supply. I have a voltmeter here to help me. I'm going to change the voltage from about 5.9 volts to about 7.7 volts. After about 30 seconds, it is clear that the shorter pendulum now has large amplitude oscillations, while the longer pendulum has small amplitude oscillations. This is because the excitation frequency is now a better match for the shorter pendulum. Notice that the distance the bar is moving is still the same. It has been the change in excitation frequency which has produced the changes in the motion of the two pendulums. Now I will change the voltage and the driver frequency back so that the driver frequency matches the frequency of the long pendulum. And now we see that the long pendulum again has larger amplitude motion. Here are some close-up still images of the device showing the motor and the gears. Here is a graph I made using this device. For many different voltage settings, I measured the frequency of the horizontal bar and the peak-to-peak amplitude of the swinging for the two pendulums. The graph shows the effect I just described, with peaks in the motion at 1.1 hertz for the long pendulum and at 1.5 hertz for the short pendulum. This graph is very similar to the first graph on the resonance page of Wikipedia, which has more information. Thanks for watching.